All right, let's jump right in. If you've spent any time with NS3, you know how it goes. You're tweaking your simulation, and every tiny change feels like it takes forever. Well, today, we're going to talk about a feature that will completely change your workflow for the better: command line arguments.
So, if you've run through the first .cc tutorial, this line should look pretty familiar, right? You're just setting a data rate for a link right there in the C++ code. And that's totally fine when you're just getting your feet wet. But what happens when you want to test your simulation at 10 megabits per second, or 50, or maybe 100?
You know the drill. You have to dive back into the code, change that one little string, save it, and then kick off a full recompile. It's this super tedious cycle, and honestly, it's a massive drag on your productivity, especially when you need to run a whole series of experiments. I like to call this whole process the recompile run cycle trap. It's that frustrating loop you get stuck in where your research just grinds to a halt because you're tweaking these parameters one by one. It's a workflow that just doesn't scale at all. I mean, let's just walk through how painful this is. First, you hunt down the line and edit the code. Then you run /ns3 build, and you wait. Then you finally run the script. And then what? You got to do it all over again for the next value. If you want to test 10 different data rates, that's 10 separate time-sucking recompiles. There has to be a better way.
And of course there is. This is where we escape that trap. We're going to talk about the elegant solution to this whole mess using command line arguments. This lets you control your simulation from the outside without ever having to touch and recompile the source code.
So what are they really? Think of them as little instructions you give to your script at the exact moment you run it. Your C++ code is written to be flexible, to listen for these instructions instead of having values hard-coded. What does this mean? It means one single compilation can power literally infinite variations of your experiment.
And the best part is the NS3 build system, the NS3 command, makes this incredibly simple. It's got a special syntax designed just for passing these arguments along to your script. Let's look at the two main ways you can pull this off.
Okay, so on the left, you've got the -command template. That %s is just a placeholder for your program's name, and everything that comes after it gets passed along. On the right is what I call the quoted wrapper. You just wrap your program and all its arguments inside single quotes. Honestly, for most day-to-day stuff, that second method is way simpler and more direct. So, theory is great, but let's see this thing in action. I mean, how do you even know what you can change from the command line in the first place? You can't just guess, right? Well, NS3 has this fantastic built-in little discovery tool just for this purpose.
Meet your new best friend, the -print help argument. Seriously, when you pass this to pretty much any ENS3 script, it doesn't actually run the simulation. Instead, it just prints out a complete list of all the parameters that the script's developers have made available for you to control.
Check out this command. We're using that simple quoted syntax we just talked about. You run first with -print help, and boom, the simulation doesn't run. What you get instead is a perfect roadmap of every single attribute you can control right from the command line. No more digging through C++ files.
And this isn't just for changing simple things like data rates. This gives you really fine-grained control over some of the more complex tools, like the test runner. You can see here, using the command template, we can tell it to run a single, specific test suite. Now that is some precision that's absolutely essential for serious debugging.
Okay, let's pull all this together and talk about why this really matters. Switching to a command line workflow isn't just a neat trick. It's a fundamental shift in how you can approach your research, making everything faster, way more scalable, and a whole lot more reproducible. So the bottom line is this. You get a massive efficiency boost because you're not waiting for compiles anymore. This makes your work scalable. You can write a tiny shell script to loop through hundreds of different parameters overnight. You get the flexibility to change anything you want on the fly. And you get discoverability. You can use -print help to see what any model is capable of. This is really how you go from being a casual NS3 user to a power user.
So I'll leave you with this question. Think about the project you're working on right now. Think about all those parameters you've been changing by hand over and over. What simulation are you going to supercharge first? Give this a try. I promise you, you will not go back to the old way.